G'day viewers, well, this is the best of them all. Got the best CRT out of them all, so this has got a bit of bleeding on it. Try not to, still won't wreck it yet, I'll keep, still keep it as a TV project, but I just can't help myself, I've got to do it. Everyone else has been doing it, so what I'm going to do, the old flyback arc trick. I think the high 1 voltage one rule started this trend. I'll power it up and just arc to it with its original flyback and see what it does. Get the pliers ready, get the variac and everything set up, and we'll see what happens. Yeah, might as well do it. Just to experience the thrill, so to speak, of the flyback arc. Yeah, here's quite a nice flyback. You can get a nice big chunky primary winding around that too. It's a shame because those flybacks, you don't come across flybacks with that bigger ferrite on it much nowadays. So let's start having some marking fun. I have a little thing with the emergency stop button on it, so I can because it's not really good to arc like that. That's probably going to get hot, so that's the main ballast resistor in a flyback or horizontal output circuit, which is part of what's running the flyback in the power supply. And that's the yeah, it's probably the driver transistor there. So I won't want it for long. I'll do a couple of arcs and that's it. I won't pop it. Hopefully I don't damage anything. I won't plug it in yet till I've got it all set up. Safety first. Okay, thick insulated rubber handle pliers. Voltage is okay. Nothing. Absolutely nothing. There we go. Corona. Discharge, unplug safety first, discharge that. Unplugged, definitely unplug safety first, as you can see. Yeah, heatsink's cold, everything's discharged, nothing's hot there, no hot transistors, that resistor there. That resistor's warm, it's a 10 ohm. Let's see, it's a 10 ohm 5 watt cement resistor, an IRH Australia. It's a replacement resistor by the looks of it. Yeah, interesting. That resistor's been replaced before, so that one's been cooked before. Yeah, nothing got too warm, no smoke, so there we are. There you go, just had to do it, just had to get the thrill of it. Alright, let's try something else. The electricity meters. Now, I've had a bit of a careful look around here. In order to phantom load a CT meter, I can't actually do it with it versus a normal direct meter. So I obviously can't go over the 15 amp current rating. I don't want to fry the load coils. So I might have to direct wire this one and time it somehow. It would be accurate being it's fairly recently recalibrated for the quality of this meter is. Anyway, it's a email Westinghouse Watthour meter type SDMP T, made in Australia, 3 phase, 4 wire behind that sticker, 277.7 meters per kilowatt hour, 50 Hz, 2.5 to 15 ACT. Well, it's a current transformer, so it's a CT meter, T40 volt, 0.9 watt hours per pulse. There's a LED there, 180-5. Multiply reading, that sticker's been taped over with this one, K equals 80. Now, I've got careful wind out on the camera tripod. I've poured some copper snot glue out of here to see if there was a terminal block behind here for this wire. Well, there isn't. It's actually terminated inside here, inside the meter itself. Now that wire is like a USB cable. It's got grey, white, red and yellow wires in it. So I could probably replace that with an ordinary USB cable. Now this would have went to a remote register, like that little Sangamo one that Raymond Watthour 2007 has. So if I can find something like that to pulse with this meter, I can have a good remote register for it. Anyway, let's dig out my spare cord stash and direct wire this thing, because I don't want to, as I said, I can't get it to run with this meter when this phantom load set up. There's too many differences, so let's just direct wire it for safety. I don't want to push it too hard, being a CT meter, being direct wired. Okay viewers, everything's all checked out nice and safe. I've got the column heater on, set to its lowest setting, so 5 amps. So I won't pull much of this one. Plug it in there. Let's get going here. Right in there. Heater's on. Flat out. Okay, in there, going in there. Active out, in, out, out. This might be a different one because it's got a pulsing in it, so this meter might be a little bit different. Should be a lot faster than a standard 3-phase meter. Interesting. Anyway, bit of a duh moment. The current transformer meters. Now, the difference, the potentials on these are not connected in a terminal block. You have to link them, connect them manually. They're not connected in the same terminal block arrangement like most standard normal direct meters are. These current transformer meters, potentials are separate in a terminal block, so you have to make some jumper wires when they active in to each of the little potential connectors. I just realised that. I wonder why my phantom load didn't work. I'll do a little quick test direct wire and then get back to phantom setup and see how it works. Yeah, because I just looked closer and there's no screws. It's just yeah, they haven't got the they've got their own separate little connector instead of the screw where it bolts in and it's bolted permanently to the main terminal block. This one doesn't have that, so you have to manually connect each of the potential coils, which is something it just clicked. Okay, now it's going to work. Now the potential's all wired up. Aha! Now we're getting somewhere. Heater on. Now we're getting somewhere. 0.9 watt hours per pulse. So figure out which one. 0.9 watt hours. Turn that one off. There we go. Now we're getting somewhere. Get that lined up perfectly on this one, then we can do a phantom load. Now it says if the red LED glows, contact region metering officer. So that means there's potential there, but something has to be hooked up to this other connector. There's other 4 wires, remote wire thingy going into it. Interesting. And that should pulse like normal. Off. Alright, let's turn this off and get set up for a phantom load. I think this is going to be accurate. Just got to figure out how this pulse circuit here works. Interesting though. It's a very interesting meter, this one. Anyway, we'll just unplug that safety first. Yeah. Alright, let's get cranking the variac up slowly. Get my clamp meter out first. I don't go over or exceeding any current limit here. Alright. Was it 2.5 at 15 amp? So if I go to that's it there, 15 amp. There we are. I can see, it might be a bit difficult here, but I think so far it's looking good. A bit on the lean there. Okay. Yeah, let's go a bit fast on this one because it's measuring potential coils of this one. That one's 66.6 revs per kilowatt hour, this one's 277.7 revs per kilowatt hour. But I think so far so good, as far as I can tell. They're both going pretty good, they're both neck and neck. Interesting, that LED there. If it glows, contact the region metering officer, so it must pulse, not glow continuously. So now it's just acting as a pulse potential indicator. It's staying on. Interesting, I have to look into that. Yep, spot on. Spot on. Be a bit of a slow test, but I'm not pulling much off the grid. I'll do a 1/10. Do a 1 kilowatt hour on this, take ages, this amount of current. So it's about 1/10. Yep, they're both 1/10. Yep, they're both advanced exactly 1/10 of the kilowatt hour. So we'll power down, unplug those as safety first. That's it, that's 100 watt hours exactly, clocked up on both meters, so it's accurate. Now, time to give it a bit of a dust up. It looks pretty good, not much scratches or scuffs on that one. It's a nice new looking meter. That's to be done. All done. Just need a little bit of a light dusting over. This thing's in pretty damn new condition. There it is there. If read below the glass, contact region meeting officer. MT87-9M. Interesting. I wonder if it's some sort of date code. There's no actual date code on this thing. It looks, that era is late 80s, early 90s, say, when Westinghouse was actually more involved in this later email metering department. So I guess it's possibly 1986, 1987 this was made. Now this is, I've got to work how this connects. This goes in there and terminates to here. Must go to some sort of remote register. Something must power this to pulse that. So this function here actually works. Because it just stayed on continuously, it didn't pulse. So something goes on there to make that pulse to a remote register. So it works and it's all accurate apart from this pulse working. So I'll have to look into that. Anyway, this thing's all nice and clean and restored. Thanks for watching.